Hello and welcome back to another video on our topic on differentiation. Today we have a very important topic that we're going to be covering today, and that is going to be equations of tangents. Now, before we get in how to work out the equation of a tangent by using differentiation, we need to cover what we actually mean by a tangent, as this is the first time you might have heard of it. Well, as you can see in this diagram here, we have some sort of curve, which is this black line like this. Now we call the tangent a straight line that touches the curve at only one point. So as you can see here, this blue tangent is a straight line that touches the curve, the black line, at only one point right here. Now, as we already know, the gradient of a straight line is constant, and we can also determine the gradient of a curve by doing differentiation, and we can work out at a particular point. So we can consider the straight line as it touches the curve at a point, and we call that the tangent. Now, we would say that the gradient of the tangent to the curve, so the gradient of this line, this tangent to the curve, has the equation. So we'll say the gradient of the tangent to a curve, and we'll call the equation of the curve y equals some function f of x. We would say at the point x equals a. So we're working out the gradient of the tangent to this curve at the point here where x is going to be equal to some value a, we would say is given by, and it's given by the formula f dashed a. So it is simply just the derivative of the curve at the point x. And we would say that this is the gradient of this straight line. Now, as we mentioned in our last video on rates of change, you might find this thing here quite familiar, and that is because this is the exact same as finding the rate of change of f at the point a. And so therefore, to work out the equation of the tangent, if we are given the gradient, which we said is the rate of change of f at the point a, we know that we're going to need to use the gradient, and we're also going to need a point on the line. So once we've given these two, we know we can use our equation y take b equals mx take away a that we talked about in straight lines in National 5 and at higher. So we know we can use this to work out the equation of the tangent. So let's go into some examples. So we're going to do our first example here. I've kept up the diagram of a tangent so you can visualize exactly what is happening. And this example asks us to find the equation of the tangent to the curve with equation y equals x squared subtract 3 at the point 2, 1. Now, if you remember, we said that the gradient of the tangent is equal to the derivative, so the rate of change of the equation of the curve at a point x equals a. Now, in this case, we have the equation of the curve to be y equals x squared minus 3. So if we work out the derivative, dy by dx, we're going to get 2x, and it's just going to be 2x because the minus 3 disappears. Now we said the gradient of the tangent is the derivative at the point x equals a. Now what is our x value in this case? Well, it's going to be 2 because we have the point 2, 1, which we call the coordinates a, b, and our a is the x coordinate, which is simply 2. So we would say at x equals 2, the derivative dy by dx is going to equal 2 times 2, which is just 4. So we would say at x equals 2, the gradient of the tangent is going to be 4. So again, I'll walk you through what we've done again. If you remember, we said the gradient of the tangent is the derivative of the curve at the point x equals a. So our first step is working out the derivative of the curve, dy by dx, and then we substitute in the point x equals 2 as we're working the gradient out at the point x equals a. Now in our case, we've got the point 2, 1, our x value is 2, substitute that in to get 4, and this is going to be our gradient. So now we have the gradient, and we have a point that lies on the line, so we can use our equation y take b equals m, x take a, to work out the equation of the tangent. And we said our a and b is this coordinate here, so we're going to have y subtract 1 equals the gradient 4, x subtract 2, and then we just solve to find the equation of the tangent. So we get 4x minus 8, and I think I'll take everything over to one side, so we'll get 4x, subtract y from both sides, and then add 1 to both sides, equals 0, and this gives us the equation of the tangent to the curve y equals x squared minus 3 at the point 2, 1. Alrighty, so let's do another example here where we're asked to find the equation of the tangent to the curve. Now this time the equation of our curve is our curve is y equals x cubed minus 2x, and we're asked to find it at the point where x is equal to minus 1. So firstly, we can see that we need to work out the gradient of this tangent at this curve. So we know that the gradient is going to occur at the derivative when x is equal to the value a. Now we can see our value a in this case, we're just told is the point x equals minus 1. So our a is minus 1. But let's work out the derivative first. It's going to be 3x squared minus 2. And then we'll say at x equals minus 1, we're going to have dy by dx equal to 3 times minus 1 squared, subtract 2. Now minus 1 squared is just 1, so it's just 3 times 1 minus 2, which is simply just 1. So we would say at x equals minus 1, the gradient is 1. And it's a good practice just to write this so your examiner knows that you know that the gradient is the derivative at the point x equals a. Now we have the gradient. We said the next step is working out a point on the curve. Now we have the x value of a point on the curve. We know that the tangent, sorry. We need a point on the tangent. We know that the point on the tangent passes through x equals 1, but we don't know the y value. But we know that the tangent meets the curve at one point. So this means that the point on the curve must be the same as the point on the tangent. Now if we have the value x equals 1, we can work out the y coordinate by substituting in the x coordinate into this equation here. And why do we do this? Well, we know the tangent passes through this coordinate, and we know that it has the same point on the curve. So if we substitute this into this equation, we'll find the coordinate of y at the point where x equals 1. So we'll also say at x equals minus 1, the y coordinate is going to be minus 1 cubed minus 2 times minus 1. And this is going to give us minus 1 cubed is minus 1. Minus 2 times minus 1 is just plus 2. So the y coordinate is just going to be 1. So with this y value, we can now create a point and say that at x equals -1, y equals 1. So this is the coordinate -1, 1. So now we have the gradient and we have the point. We can simply say with our equation, y take b equals m, x take a. In this case, this is RA and this is RB and this is RM. We're going to have y take 1 equals, now in this case our m is just 1, so there's no need to write 1. We'll just do x take a, which is just going to be +1 because it's -1. So it's going to be x plus 1. And now we'll rearrange to get the general equation, which will give us y take x from both sides, and then take 1 from both sides, equals 0. And we call this the general equation of our equation to the tangent to the curve with that equation. Okay, so for our third example of today's video, we're going to do an example that's a more visual example. We've got a bit of a diagram going on in this case here. So we have a function f, which is defined for x greater than 0, by the function f of x, which is equal to 1 over x. And we are asked to find the equation of the tangent to the curve y equals f of x at the point P. Now this time at the point P, we know that P has the y value 2. So in order to work out the gradient of the tangent to the curve, we need to work out the x value at the point P, which has the y value 2. Now we say that y equals f of x, so because, in fact I think I'm actually going to do this up here. Now because y equals f of x, we can simply say that y equals 1 over x. Now at the point y equals 2, we can work out what the x value is by just rearranging. So what we would do here is we can multiply both sides by x to get 2x equals 1, and then divide both sides by 2, or we can simply just divide. We can do 1 divided by both sides. So we would find that x is equal to 1/2. So we would say at y equals 2, x equals 1/2. So the point P is going to be the coordinates 1/2, 2. And now we have this point P here, which meets the tangent and the curve at the same point. So our x value is going to be 1/2. So this is our A, if you like, in this case. Just going to label it A and B, which will be useful for later. So now we can work out the derivative f dash x, which is going to give us, well, we need to actually make this easier for us to differentiate. So if you remember, we prepared to differentiate by saying that 1 over x is simply equal to x to the -1. So our derivative f dash x is going to be -1x to the -2, which we can rewrite as -1 over x squared. And now we can say at x equals 1/2, we would say that f dashed of 1/2, so this is the point at x equals 1/2, we're working out the gradient, which we said is the derivative at the point x equals a. So we substitute x in to be 1/2, we get -1 over 1/2 squared, which is just -1 over 1/4, which is just going to give us -4 over 1, which is just -4. So we would say at x equals 1/2, the gradient is equal to -4. So now that we have the gradient and the point on the line, we can work out the equation of the tangent by substituting everything we know into this equation. We get y take 2 equals -4, x take 1/2. We'll expand everything here to get -4x. -4 times -1/2 is just +2. And then we'll take everything over to one side, add 4x, subtract 2 to give us the equation of the tangent. So as we said in our video on finding the derivative, the best way to get practice at working out equations of tangents is just by doing lots of examples. So the next couple examples we're going to do are a bit more complex, so they might be a bit more exam style examples. So let's get straight into them. So for this first one, we are asked to find the equation of the tangent to the curve where y equals cube root of x squared at the point where x is equal to 8. Now we can immediately work out the derivative of dy by dx and therefore work out the gradient because we have the point x this time. But this is quite difficult to differentiate. So we'll start off by preparing to differentiate by saying that the cube root of x squared is the same as x to the power of 2/3. And now we can differentiate to find that dy by dx is going to be 2/3 x, and then 2/3 minus 1 is going to be minus 1/3. And because we've got this negative power here, I think we'll rewrite it. So we'll say this is equal to 2 over 3x to the third. And again, I don't like this because we've got this third. So we'll write 2 over 3 cube root of x. And now we can work out the gradient by saying at the point where x is equal to 8, the derivative at x is equal to 8 is going to be 2 over 3 cube root of 8. Now the cube root of 8 is just 2, so we're going to have 2 over 3 times 2, which is just 2 over 6. And 2 over 6 is the same as 1/3. So we would say at x is equal to 8, the gradient of the tangent to the curve is going to be 1/3. Now we do not have a point where the tangent meets the curve, but we do have the point x equals 8. And we can work out the y value by just substituting it in to this equation here. So we would say that y, I think actually we'll just say at x equals 8, y is equal to the cube root of 8 squared. Now we said the cube root of 8 is just 2, so this is going to be 2 squared, which is equal to 4. And now we have the point, and we'll just call it P, but we'll just say that it's a point. So we'll just say the point at x equal to 8, y is equal to 4. So we're going to have the point 8, 4. And now we have a point and we have the gradient, so we can work out the equation of the tangent, saying this is A and this is B, and we get y, take 4, is equal to 1/3, x take 8, multiply everything through by 3 to get rid of this fraction. We're going to get 3y minus 12 is equal to x minus 8. And then take everything over to one side, we find that we get 3y minus x, then add 8 to both sides, gives us minus 4, is equal to 0. And this is our equation to the tangent to the curve y equals cube root of x squared at the point where x is equal to 8. So we'll do one more slightly trickier example to finish off this video. And we are told that a curve has equation y equals, and oh boy, we've got a lot of fractions here. We've got 1/3 x cubed minus 1/2 x squared plus 2x plus 5. So quite a few terms in this. It just means a lot of differentiation. And we are asked to find the coordinates of the points along the curve where the tangent has gradient 4. So this is slightly different this time. We are not actually asked to find the equation of the tangent. We are asked to find the point on the curve where the tangent has gradient 4. So how do we do this? Well, we know that the derivative gives us the gradient of the tangent, correct? So we would simply say that dy by dx in our case is going to be, well, we just multiply by 3. A third times 3 is quite easy because it's just 1. So we're going to get x, take away 1 squared. The same thing works here. We're just going to have minus x. Derivative of 2x is just 2. And the derivative of 5 is just 0. So this is going to be our equation of the derivative. Now we are told that the tangent has gradient 4. Now because we know that the tangent is 4, and we also know that the derivative at a point x equal to a gives us the tangent, we can simply say that 4 is equal to this equation here. And now what we need to do is just solve for x. So let's just rearrange to say that x squared minus x, take away 4 from both sides, subtract 2 is equal to 0, and we'll just solve to find x. So we're going to get x here, and it looks like we're going to have minus 2 plus 1. So we know that x is either going to be equal to 2 or x is going to be equal to minus 1. Now, as you can see, we have 2 values for x. So if we're asked to find the coordinates of the points along the curve where the tangent has gradient 4, we know that there's going to be 2 points at which the tangent meets the curve. So we can work out these points by substituting the values x equals 2 and x equals minus 1 into our equation y equals a third x cubed such and such. So we would say, let's do at x equals 2. Now I know I did say that a tangent only touches a curve once. Well, that is correct, but it looks like in this case we have 2 tangents. Or the tangent has gradient 4 at 2 different places, we should say. So at x equals 2, y is going to equal a third 2 cubed minus a half 2 squared plus 2 times 2 plus 5. And this is going to be 2 cubed, which is 8. So we're going to get 8 over 3. 2 squared is 4, so we'll get minus 4 over 2, which is just minus 2. And then we're going to get 2 times 2, which is 4, plus 5. And now we can just simplify this to get, let's put everything in terms of 3. So a over 3 minus 6 over 3 plus 12 over 3 plus 15 over 3. So 8 minus 6 is 2, plus 12 is 24, plus 15 is, 8 minus 6 is 2, plus 12 is 14, plus 15 is 29. I was confusing myself there. So we would say at x equals 2, y is the point 29, 3. And we would say at x equals minus 1, this is going to be slightly easier this time. We're going to get y is equal to a third minus 1 cubed minus a half minus 1 squared plus 2 times minus 1 plus 5, which we can see is going to give us minus 1 cubed is minus 1. So we'll get minus a third. Minus 1 squared is just 1. So we get minus a half. Plus 2 times minus 1 is minus 2, plus 5, and this time we'll change everything again to give us over 3, so we'll get minus 1 over 3. In fact, actually, we're going to do it over 6 to make these a common denominator. So we get minus 2 over 6, and then we're multiplying this by 3 to get over 6. So we get minus 3 over 6, and then we're going to get minus 12 over 6, and we're going to get plus 30 over 6, which is simply going to give us minus 2 minus 3 is minus 5, minus 12 is minus 17, plus 30 is going to give us 13 over 6. So a bit of working with fractions here, and we can just say down here, the points are, and we get when x is equal to minus 1, that y is going to be 13 over 6. And when x is equal to 2, we get 29 over 3. So a bit of working with fractions in this question to work out the points. And it's still to do with the equation of the tangent, but just a little bit different worded and working at different things at different times.